Hello friends, welcome back. Hearty welcome to you. In this session, we will see a problem related to geometric progression. We have been given that pth term of a geometric progression is q and qth term equals to p. We need to prove that p plus qth term equals to q power p divided by p power q whole to the power of 1 by p minus q. Now what is our approach to solve this problem? We have been given two conditions, pth term is q, qth term is p. So when we write down the formula of nth term of a geometric progression, we have two variables a and r. So using these two conditions, we'll find out the values of a and r. Then we will substitute in the formula for p plus qth term. So let's go ahead. Let us say that the geometric progression is, let our geometric progression be ar square, like that. Nth term is given by ar to the power of n minus 1. Now, first condition is pth term is q. ap equals to q. Second condition is aq equals to p. Now, ap equals to q. Substituting in the formula, we will have a into r to the power of p minus 1 equals to q. Similarly, for the second equation, we will have a into r to the power of q minus 1 equals to p. This is our equation number 1 and this is our equation number 2. Now let's first try to find out the r value. For that, what we will do? We will divide 1 by 2 and we will see what happens. A and a will cancel. We will have r to the power of p minus 1 divided by r to the power of q minus 1 equals to q by p. Simplify that. We will have r to the power of p minus 1 minus q plus 1 equals to q by p, or we have r to the power of minus 1 and plus 1 will cancel. We will have r to the power of p minus q equals to q by p, or r equals to q by p whole to the power of 1 by p minus q. So we got r equals to q by p whole to the power of 1 by p minus q. Let's go ahead. Now what we know? We know that a into r to the power of p minus 1 equals to q. A into r to the power of q minus 1 equals to p, and we just got that r equals to q by p whole to the power of 1 divided by p minus q. What we need to find out? We need to find out what is p plus qth term. Now when we want to write p plus qth term, what it will be? Let us see. It will be according to the formula. First term a into common ratio r whole to the power of n minus 1. That means p plus q minus 1. We already calculated r value. We need to know the a value. If you are able to find out the a value, then we can just go and substitute. So let's go ahead and find out a value. For that, we will take this condition and we will say that a into r to the power of p minus 1 equals to q. Then a equals to q divided by r to the power of p minus 1. But what is r according to us? R is q by p whole to the power of p minus 1 divided by p minus q, because r is q by p whole to the power of 1 by p minus q. That is what we got, r equals to. So when we want q divided by r to the power of p minus 1, it will become q by p whole to the power of p minus 1 by p minus q. Let us simplify this. This will be q to the power of 1 divided by q to the power of p minus 1 by p minus q, and multiply that with, this will go to the numerator, the p. We will have p to the power of p minus 1 by p minus q. Let us simplify that. That will be q to the power of 1 minus of p minus 1 by p minus q, multiply with p to the power of p minus 1 by p minus q. That will give us, when we take LCM, we will have p minus q minus p plus 1, that is q to the power of minus p and p will cancel, you have plus q to the power of 1 minus q by p minus q, multiply with p to the power of p minus 1 by p minus q. This is the value of A. So this is A. We know what is A. We also know what is R. What we want is A into R to the power of p plus q minus 1. So whatever we got A and R values, let's go ahead and substitute here. So we'll write down A of p plus q equals to A is nothing but q to the power of 1 minus q divided by p minus q, multiply with p to the power of p minus 1 divided by p minus q, multiply with r to the power of p plus q minus 1. What is our r? R is q by p whole to the power of 1 by p minus q, and we are doing to the power of p plus q minus 1. So p plus q minus 1 will come here. Now let us simplify this. We can write it as q to the power of 1 minus q divided by p minus q, multiply with q to the power of p plus q minus 1 divided by p minus q, divided by, in the p we will have, into p we have p to the power of p minus 1 by p minus q, divided by, this part we have to write, that is p to the power of p plus q minus 1 divided by p minus q. Now let us separate q terms and p terms. Q we will have 1 minus q plus p plus q minus 1, 1 and q will cancel. So write it down 1 minus q plus p plus q minus 1 by p minus q divided by p to the power of, let us get this to denominator, we will have p plus q minus 1 by p minus q minus p minus 1 divided by p minus q. This will be equal to, now I can cancel here, 1 and 1 will cancel, q and q will cancel. Here when I simplify that, p and p will cancel, 1 and 1 will cancel. So it will become q to the power of p divided by p to the power of q whole to the power of 1 divided by p minus q. So if pth term equals to q and qth term equals to p, then p plus qth term is equals to q power p divided by p power q whole to the power of 1 by p minus q. Now how we have solved this? We know that the nth term of geometric progression is given by a into r to the power of n minus 1. Where a is the first term and r is the common ratio. Here we have been given two conditions, that pth term equals to q and qth term equals to p. Using that we can solve them and find out a and r values. Once we got a and r values, we can go to p plus q term formula and substitute a and r values and simplify that appropriately. We will get q to the power of p divided by p power q whole to the power of 1 by p minus q.